Solid triangles. This is now three-dimensional. When they did sketch it in your book, they've got it like with a grey colour here. And they can even put little stripes there. But they're saying there in words that this is three-dimensional because they're saying A and B and C are in the same horizontal plane. So that means the triangle is drawn on the ground. And then A is the foot of a mast or a pole or something like that. So that means that has to be perpendicular. So the mast is perpendicular to the ground. That is definitely not 90 degrees if we measure what's on the board there. But that's the representation that we've got, that it's a perpendicular mast and the ground. It has to be perpendicular to each other. Are you with me? Now, they also said that these are both lengths of x, and these are both angles of A. So the first thing that we always do is find all the A's and the X's and the whatever that we can find. Now we only know that these angles are alpha, alpha, and 90. So the only other angle that I can find is
90 minus alpha.
Angle D, that's 90 minus alpha. So I've got all three the angles in the first triangle. And I've got only an angle and a side in the bottom one. Are you with me?
Yes, ma'am.
Can I not say that whole angle there is 360? Why not?
Oh, it's
three-dimensional, guys. That appears on my board that is flat to be a revolution, but it's not. Remember that this is the ground, and there goes the mast. So you cannot say that they added together will give me 360 because it doesn't. It's not flat like on the board. You've got to realize that this is horizontal plane and this is standing up. You cannot add this angle and that angle together and get 360. Are you with me? Be careful for that, because things look like it can, but it can't because of the three-dimensionality. The question here was, prove to me that BC is equal to something, something, something. Now first of all, BC is in this bottom triangle, not in this top one. So can I start in the bottom triangle? No. Why not?
Have to find a common.
Not enough information, because only one angle one side doesn't make it. There's nothing I can do to find more angles there, so I've got only one angle on one side. What then?
Find a common side.
Get the connecting side or the common side by first starting off in triangle
A, B,
A, D. I'm going to get
or BA.
B, the connecting side. Right. So if I want that connecting side, then I've got to realize there's also my tools that I can use, which is normally the sin rule or the cos rule, but you can also here, because it's a 90-degree triangle, use your grade 10 sin, cos, and tan ratios. You can, and it's faster. If you use the sin rule, can you use the sin rule?
Yes.
What do you need for sin rule? Two things. So basically you've got an angle at a side and an angle at a side, of which one can be missing. So you need at least 3 pieces of information. So I have side, and all the angles. And I'm searching for that one. So if I want AB, I'm going to put AB at the top. But please remember, I taught you, always first write down the
formula.
Okay, so the sin rule, whether the triangle is ABC is irrelevant. You write ABC whether it's X, Y, Z, it doesn't matter. I can see you know what you're doing. Then we're going to say for finding AB, I'm going to put AB at the top, and then at the bottom it's going to be sin. So it's AB. This one that I'm looking for. The angle is
90 minus alpha.
90 minus alpha, which is a what sum?
Co-function.
Co-function. Hoof path. The other pair that I've got, which is the other side that I have? X. And its partner sin?
90.
Okay, but what is a 90? 1. So I can write it, but I don't have to. In the next step, it's just going to disappear. And I'm going to have X over 1. And on the other side, AB over?
Cos.
Because I did a poof puff co-function reduction formula. So that my AB answer is X cos alpha. So these are the little bit more higher level sums when it's all in terms of alpha, beta, theta, x, y, whatever. If it's degrees, it's a little bit easier for most kids. Which one am I going to ask in a test?
Both.
Any which one. Because normally there's only one of these solving triangles, normally. Okay. So if I've got AB, then I can go to triangle.
A, B, C.
To find.
B, C.
Okay, now this doesn't count marks, guys, but present your answer so that the guy marking knows where you are, where you're aiming for. And again, can I use my sin rule?
No.
Because now I've got this side, remember? This side is now x cos alpha, and usually there's not enough space to write it here, then I just say tick, I've got it. So what do I have in this bottom triangle?
2 sides and a common angle.
2 sides and a
Common.
included angle, which means I can't use sin. And I had a good idea.
With the roots.
To get an answer of a side with a root in it, it should have been Carl's rule. Because Carl's rule has a square, and then I square rooted to get to a square root. So that actually indicated to me that it could be a Carl's rule that I'm using. So the Carl's rule states what?
A squared.
A square is equal to
minus 2AC alpha.
Okay, and you know that is on your information sheet. All the stuff last year that you had to study is now on the information sheet. But you've got to know that information sheet. No, this isn't there, but this and this and this is. Know your information sheet. And when you're wanting to look for it just to check it, you know it's there, it's there, it's there. So that you're not searching for it. And afterwards I say, but this was on the information sheet. You said, really? Okay, please, you must know your information sheet. So I have 2 sides in the included angle, and that's exactly what this is aiming for. Because remember, if I've got ABC, my triangle, and it's small a that I've got, that I'm looking for, and I need the B, and I need the C, and I need the A. It means I need 2 sides in the included angle. There's the 2 sides and the included angle. So for AB, which is now BC, right? Squared, it's going to be, which one first? Doesn't matter. This one squared plus that one squared. But please be careful, it's the whole thing squared. Which is going to be what?
X squared.
X squared cos squared. Okay, careful with the algebra. And then the last bit is just minus 2 times the x cos alpha and the cos A. Just be accurate, careful, particular. What is this when you simplify?
X squared.
Minus 2x squared.
Cos.
Oopsie, I'm sorry. A, what's the value of A? Alpha, right? Okay. Didn't substitute it. And then this answer would be x squared. Cos squared. Again, are you with me, everybody?
Oh, yes.
Okay, now normally what would be your inclination then in the next step? I'm going to add them and get 2x squared. No, ma'am, I can't do that. Can you see that some kids will now want to tell me 2x squared? Why can't I do that? This is a unit. You can't take that away. This is adding and this is timing. You can't add a little bit and then time. It's order of operations. So you can't add that. But what else can I do? It's like terms. X squared cos squared, x squared cos squared. It's like adding algebra. So it's plus 1 of them and minus 2 of them is going to give me minus 1 of them. Now I already did this sum with another class, and then they did something that I like. Because they were searching for the answer that they've given me. Remember, that's like a quick note. I know where I'm aiming. And I know that I'm aiming for cos 2 alpha, meaning I need a double angle. There's no double angle here, unless I particularly search for it. So what those guys did, and we can do it on different ways, but let's go for that one because it's a nice easy one. Remember, if you can get a question like this is like about 6 or 7 marks, and you can get 3, 4 marks out of the 7. We're quite happy with it because it's higher level. Okay? So the easiest way of doing it would have then been to say, let's take out a common x squared. Why? Because I'm aiming for the prize. And if I take out the x squared, it's going to quickly become, when I do the square root, it's going to come out and be the x that they're asking me for. Okay, so I'm taking out an x squared. What's left is 1 plus cos squared minus 2 cos squared. Now I'm doing what somebody else had the idea of that I liked so much that I'm showing it to you. Because if I do that, what's this? It's that cos double angle already. What are we inclined to do? Add the like terms, which is right, and then what? Then you've got to split them up again. Because you need it to be split up to get to a double angle formula. Because the double angle formula states 2 cos squared minus 1. I'm aiming for minus. So that means I'm aiming for 1 minus 2, which is there. You see it? It's not easy. So that 1 minus 2 squared is going to be equal to minus cos double angle. Only because I'm being led by where I'm going. And then this will stay what it is, the cos squared. And I'm still busy with the x squared there at the outside. And the reason it becomes in a square root is because this side was square, and then when I square root it, this will only be x, and this root will stay inside the root. If you wanted to, you could put the whole thing in a root first, knowing that you can take out the x squared, because you can take out squares from the roots and make it just x. But why can I not take out this square? Because of that? Minus. If it's times, 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 everything inside, all the squares can come out. But this one cannot. Only because I timed it, that one could come outside. And that was the easier way of doing it. But, ma'am, we're so inclined to always add the like terms. If you didn't, you were helping yourself. Now, if you did, you would have gotten to minus 1 x squared, or cos x squared. Then you'd have to split them up again and force it to be this identity again. How would you take the minus cos square again? You'd have to go change it back into cos square minus 2 cos square, which is a difficult one. How many marks for this last complicated bit?
5.
How many marks for the last bit? 1, maybe 2. So if you could get here, you might have lost a mark, maybe 2. Okay? Please remember time. If this was 7 marks and you're on 10 minutes and 11 minutes, stop. Go on with the next sum. You can't give more time than that to a sum, especially if it's difficult and you're trying so hard to get to the answer but you're not getting it, then you leave it. We are happy with 4 out of 6 and 4 out of 7 rather than 0, not attempting it at all, because the first parts were fine. Okay. Again, with the three-dimensionality, they're saying that this is perpendicular to that. So this is like ground and going up for a mast or something like that. Then they also said at the top there by A, when you're looking down at B, this is an angle of depression. When you're standing here by D, looking up at that post there, you're on level ground with the sea. Here I am, and there's the door. And I'm on level ground, so it's there where the door is or where the post is. Are you seeing the three-dimensionality here? Then they said from D, looking up there at that post, I've got an angle of elevation. But usually they say all those words, but it's there anyway. Now, if I'm there at A, looking down, this should be a what thing? Horizontal. And then this will also be horizontal. If I really wanted to, I can draw in a triangle here and say this is ground again. This is all on the ground. So this horizontal line and that horizontal line should be parallel. All horizons should be parallel to each other. They also say that that angle there is 2x. This side here is 3 meters. There's an angle of x. There's a y. First thing that you do before you even know what's going on here is find every
Angle.
angle. Can you?
Yes.
Namely,
90 minus
that's
y.
going to be 90 minus y because the sum of the angles of a triangle. And what else?
I thought 90 minus x.
90 minus x.
I thought 90
How come
minus
90?
x.
Because a horizontal mast or flagpole or whatever is always going to be perpendicular to the horizontal. I just said horizontal. Vertical and horizontal should be 90. And the same here at the bottom,
90
that
minus
should be 90 because it's vertical, horizontal. They never said that. You had to know that. So that means if that is x, I'm having 90 minus x. Will I be able to find this angle?
Yes.
Okay, and what was the question? DC, okay. Can I find this angle here?
Yes.
How?
Incorrect.
Okay, now what would that look like? And do I need to see it all?
No.
Not necessarily, but if you want to go work it out, then this angle here, C1 would be 180 minus the 90 minus the x plus the 2x. Everybody with me? If I add that all together, this is going to be minus 90. The plus 2x is going to be plus x minus is going to be minus x. So the answer is going to be 90 minus x. 90 times a minus, this is plus x times the minus is a minus x. So this one is 90 minus x as well. I don't know if I'm going to need all of this, but I'll usually just go get all the angles. What does that tell me about this triangle?
It's an isosceles.
Isosceles. So that should be 3 meters. And because I've already done this, this is why I'm aiming for it. The last question was find AB. I'm done with it. I can already say that AB is. Now remember, I'm not in geometry, so you don't have to tell me. Some of the angles of a triangle, sides opposite equal angles are equal, and that's the reason why they're both going to be 3. But I've got it already. If you didn't work it out already, you'd have to then for the last one, but I've already worked it out. So, where do we start to first find DC, obviously in triangle? ADC, and tell them. Can I use the sin rule? Yes. Can I use grade 10?
Yes.
And say with this at Y, and this angle, and the sine, oops, I missed something, this was H.
Yes.
Sorry, this was H. So find DC in terms of Y and a trig ratio. So find DC in terms of Y and a trig ratio. The only side I've got in terms of something is H. You have to have at least one side. You can't have a triangle with no sides. You can do nothing with that. So if this is the side, I can find out this side by using for Y the adjacent over the opposite, which can be 10. If you want to go for the grade 10, you could have then said 10 of Y is the opposite, which is H over the adjacent, which is DC. So DC would be equal to, what just happened there? Cross multiplication. And that was chop chop. The alternative, if I didn't use grade 10, I could use grade 11 sin rules. To find DC, you would put DC over the sin of 90 minus
Y.
Y. The other side that you've got is
H
H over the sin of
Y.
also Y. Are you with me?
Yes, ma'am.
This is a
Co-function.
co-function proof of.
Cos
So it's going to
Y.
become cos. Oh, it doesn't look at all like this side. You see it? Okay? And it's equal to H over.
CY
Okay, now to get DC alone, what are we going to say?
times
Times it there to that side. So it's H
cos Y
cos Y
over CY,
over sin Y.
which is H over 10Y.
What's that?
It's a
Converse of 10.
Yes, converse of 10. It's actually the reciprocal, it's swapped around. It shouldn't be cos over sin, it should be. So what does that represent then?
Y over 10Y.
It's 10 at the bottom. So that should be then Y, H over
10Y.
at the bottom, which is this one, much easier. Sometimes it's a better choice to go back to the perpendicular. If it's a right angle triangle, you go back to the grade 10. Much easier, much more work, much more complex. Same marks. Okay, now once I have that, they say now hence, meaning
Follow up.
use what you've got and follow up and find DC. So we've got DC to still find, but ma'am, I just found DC, yes, but now they're saying hence, prove that DC is. So you've got to find another way of finding DC. How am I going to connect this with something else? I've just done what I can in this triangle. But in the other triangle, because obviously they're wanting to work with angle X as well, and there was no angle X here. So they're saying, listen, you better get to a triangle that's got angle X as well. So that has to be this triangle. And then how's it going to connect to the other triangle? With H. So if I can get H here and come back to this side and substitute the H with whatever, hopefully I'll get to that answer there. We've already got the tan Y. That's fantastic. So I'm going to go for H in the other triangle, ABC. I'm going to find H. And to find it, hopefully, it's going to be the sin rule. It is. So it's going to be H over what?
Sin 2x.
Sin 2x, which is going to be equal to which side?
3 over sin 90 minus x.
Which 3 did you use?
I used that.
It doesn't matter because they're both 3, right? And both of their opposite angles are 90 minus. Then this would be H over, oopsie, sin 2x. There's no sin 2x. What am I thinking? Double angle. So this you couldn't do last year, double angles, and it's 3-dimensional also. And in this side I've got 3 over?
Cos x.
How am I going to get this to be something that can simplify?
Times it. Sin 2x.
Somewhere either earlier or later, you're going to have to change that cos 2x into, sin 2x into
2 sin x cos x times 3.
right? And don't forget about the 3 on the outside as well. And then you can find that they are
Cancel.
And what happens then? I've got 6 sin x. I just need 30 seconds more. So once I know that h is equal to that answer, I just go back and let me do something nice. And say, let's call this number 1, this number 2. So we're going to put 2 into 1, so that DC equal to h is going to be 6 sin x over the 10 y, and I've proven what they wanted me to prove. Luckily we've already done this in the beginning. Okay, thank you guys.